Hi everybody, I welcome you all to video lecture number 3 of chapter number 9 Science, Force and Laws of Motion. And in today's video lecture we are going to discuss the sums based on Newton's second law of motion. So what we studied in Newton's second law of motion was force applied is directly proportional to change in momentum upon time taken. And based upon this phenomenon, we have derived a formula for force, which is F is equal to ma. Force is equal to mass into acceleration. So based upon these two concepts or formulas, let us solve some examples given in the textbook. Let us move ahead. So let us start from example 9.1. Right, let us read the question and keep noting what is given in the question in parts. A constant force acts on an object of mass 5 kg. So we shall stop over here and write that mass is 5 kg for a duration of 2 seconds. Right? For a duration of 2 seconds. So we shall write time is equal to 2 seconds. Clear? It increases the object's velocity from 3 meters per second to 7 meters per second. So 3 meters per second will become our initial velocity u, and 7 meters per second will become our final velocity v. So u is equal to 3 meters per second and v is equal to 7 meters per second. Find the magnitude of applied force. We have to find the force. So we shall write F is equal to question mark. Now something more is given over here, but we shall look at it afterwards. Let us first solve this much. We have to find force. In order to find force, we have a formula F is equal to m into a. Right? So mass is given to us, but acceleration is not given to us. So we have to find acceleration from this. Find v minus u upon t, and then you can apply the formula F is equal to ma. If you don't want to do this lengthy process, there is a shortcut. We have studied from Newton's second law of motion that F is equal to m into v minus u upon t. Right? Force is equal to change in momentum upon time taken. This is change in momentum, m into v minus u, and this is time taken. અને એમ ન વિચારો તો આ બી ક્લિયર છે ને કે v minus u upon t એટલે a થાય, તો અલ્ટિમેટલી f is equal to ma. અલગથી ફાઇન્ડ કરવું એના કરતા આપણે ડિરેક્ટલી જ ફાઇન્ડ કરીને આન્સર આપીએ. Just input the values in this. Mass is 5, velocity v is 7, initial velocity is 3, time is 2 seconds. 7 minus 3 will give us 4. This 2 will cancel over here 2 times. So we get 5 2s are 10 newtons. Very simple. Let us now read it. Now if the force was applied for a duration of 5 seconds, see we are changing the time. Here the force was applied for 2 seconds. Now we are saying that we will apply force for 5 seconds. What would be the final velocity of the object? તો આ તો બિલકુલ નવું જ છે આપણા માટે. Separate question. ફરી પાછું આપણે એના માટે આવડી ડિટેલ્સ લખીએ. So again I can say that mass is 5 kg. Right, mass તો એટલો જ છે. Time પહેલા 2 seconds હતો, હવે કેટલો થઈ ગયો છે 5 seconds. So I will write time is equal to 5 seconds. Initial velocity હજી એટલી જ છે 3 meters per second. Right, what would be the final velocity? તો v મારે find કરવાનો છે, અને force જે મારે પહેલા find કરવાનો હતો, but હવે મારી પાસે એની value છે that force is 10 newtons. So I will write force is equal to 10 newtons over here. Again I am having 4 values with me and I have to find the fifth one. I will use the same formula again. F is equal to m into v minus u upon t. But only difference is previously everything else was given to me and I had to find the value of f. This time I have to find the value of v and everything else is given to me. So just put the values. Instead of f, 10, m is equal to 5, v we have to find, u is equal to 3 and time is 5 seconds, which is very important, right? Time has changed. This 5 and this 5 will cancel each other. So I get 10 is equal to v minus 3. Minus 3 will go to the other side, it will become plus 3. And finally I get velocity is 13 meters per second, or final velocity is 13 meters per second. Very easy question, right? Please pause the video and write this in your CW. We shall move to example 9.2. Let us read the question of example 9.2. Which would require a greater force? Which would require a greater force means we are having two different conditions and we have to find the force for both the conditions, and finally we have to tell which one has the larger value. So let us see the first condition. Accelerating a 2 kg mass at 5 meters per second square. So mass over here is 2 kilograms and acceleration is 5 meters per second square. I have to find how much force is needed. This is condition number 1. An object of mass 2 kg. I have to provide an acceleration of 5 meters per second square, and I have to find how much force I have to apply to achieve this. One more condition is given, or a 4 kg mass at 2 meters per second square. So I will write it separately. That mass is 4 kg and acceleration is 2 meters per second square. Again I have to find the value of force. So here and here, at both the places we will find the force F, and then finally we have to tell which one of them is having a greater value, right, which would require a greater force. So simple, mass and acceleration are given to us. What we have to do is F is equal to ma, right? So F is equal to m into a according to Newton's second law of motion. Here mass is 2 kilograms, acceleration is 5. So 5 2s are, we get 10 newtons. Same thing we shall apply over here also, right? According to Newton's second law of motion, F is equal to ma. Here mass is 4, acceleration is 2. 4 2s are 8 newtons. Clearly we can see that more force is required over here. So I will write it requires a greater force to achieve an acceleration of 5 meters per second square for an object of mass 2 kilograms. Right? Please pause the video and write this in your CW. Let us now move to example 9.3. Yes, again let us read the question and please read it very cautiously. A motor car is moving with a velocity of 108 kilometers per hour. So 108 kilometers per hour will become our initial velocity, right? But the velocity is given in kilometers per hour, and when I see ahead, the time is given in seconds. So I have to convert this 108 from kilometers per hour to meters per second. So I shall write 108 kilometers per hour into meters per second like this. Initial velocity u is equal to 108 into 5 upon 18. Right? 18 will cancel over here 6 times, and 6 5s are, we get 30 meters per second. Right? And it takes 4 seconds to stop after brakes are applied. Means car is moving at this much high velocity. We are applying brakes, means we are applying force, and it takes 4 seconds for the car to stop. So first thing is that I can write time is equal to 4 seconds. And after 4 seconds, the moving car will stop. It will become stationary. So I can write final velocity is 0 meters per second. Nowhere it is written over here mathematically. You have to understand that the car is stopping. It will become stationary. Hence I have to write final velocity as 0 meters per second. Calculate the force exerted by brakes on the motor car. બરાબર ને, ગાડીને ઊભું રાખવા માટે કેટલો ફોર્સ અપ્લાય કર્યો બ્રેથથી આપણે એ ફાઇન્ડ કરવાનું છે. તો વી હેવ ટુ રાઇટ F ઇઝ ઇક્વલ ટુ ક્વેશ્ચન માર્ક. If the mass along with the passengers is 1000 kg, રાઈટ, તો વેહિકલ નો માસ અને એની અંદરના પેસેન્જર્સ નો માસ ભેગો થઈને છે 1000 kg. So we shall write mass is equal to 1000 kg. Again you can see initial velocity, final velocity, time and mass are given. All I have to do is just apply Newton's second law of motion. Right, very sorry, the formula is not written over here. Please write the formula over here like this. F is equal to m into v minus u whole divided by time. Right, this is the formula. So instead of m I shall write 1000, instead of v I will write 0, instead of 0 I will write instead of u I will write 30, and instead of time I will write 4. Fine. Now 4 and 1000 will cancel each other. I shall get 250. 0 minus 30 is minus 30. 250 into minus 30 will give us minus 7500 newtons. Right. Now here we get a minus sign over here. What do we mean by minus sign? Minus sign indicates that force is applied in the opposite direction of motion of car. The car was moving forward, but due to application of brakes, it was not able to move forward and it stopped backward. So this force was applied in opposite direction of motion of car, which is indicated by this negative sign. Fine, so negative sign tells us that force exerted by the brakes is opposite to the direction of motion of motor car. Right, please pause the video and write this in your CW. Once you finish this, we shall move to example 9.4. Let us now see example 9.4. A force of 5 Newton. So force is given to us, so we shall write first force is equal to 5 newtons. Gives a mass m1 and acceleration of 10 meters per second square. So acceleration is 10 meters per second square and mass is m1, which we don't know. Right. Fine. Here mass m1 is written, so we will write acceleration as a1. Clear. One more condition is given, and the mass m2 and acceleration of 20 meters per second square. Again force is 5 newton only. 5 newton no force કોઈ ઓબ્જેક્ટ નો માસ m1 હોય તો એને 10 meters per second square નું acceleration આપે છે, અને એ જ 5 newton નો force કોઈ બીજો ઓબ્જેક્ટ છે જેનો માસ m2 છે એને 20 meters per second square નું acceleration આપે છે. Right. What acceleration would it give if both the masses were tied together? So again force is given to us 5 newton. We have to find acceleration if both the masses were tied together. So for that, first we need to obtain the value of both the masses. Then and then only we can tie it. So first of all, we will find the value of m1 and m2 and then we shall add that. Right. So it is very easy to obtain the value of m1 and m2. We have the formula of force F is equal to m into A. Right. Simply, instead of F I will write 5. Instead of m1 I will write m1 because I don't know its value. Instead of a1 I shall write 10. In order to find the value of m1, 10 will go to the other side. 5 will cancel over here 2 times, so I will get 1 upon 2, and 1 upon 2 is 0.5 kilograms. Same process I will do for this also. Again F is equal to ma, but here I will write m2 and a2. Input the values, take this 20 to the other side. 5 upon 20 will give us 1 upon 4 and 1 upon 4 is 0.25 kg. Now what is written? If we tie both the masses together, if we tie both the masses together. In that case, m1 and m2 will be added to each other. So total mass is equal to m is equal to m1 plus m2. We get 0.575 kgs. Again, what acceleration would it give? So I have to find the value of acceleration. Fine, and force is 5 Newton only. Right? પહેલા હું 5 ન્યૂટન ફોર્સ આને આપતો હતો, પછી હું 5 ન્યૂટન ફોર્સ આને આપું છું. હવે મને નવું પૂછ્યું તો હું 5 જ ન્યૂટન ફોર્સ આ બંનેને એક સાથે આપું તો એક્સિલરેશન કેટલું થશે? Simply after adding the masses, I will again apply the formula F is equal to ma. This time instead of F, again I will write 5. Instead of m, I will write 0.75. Now I have the total mass, right? And I have to find acceleration, so it will be kept as it is. This 0.75 will go to the other side into the denominator. Right, here I can see there are 2 digits after the decimal point, so I will multiply the numerator and denominator by 100. So we get 500 upon 75. And when I divide this, I get 6.67. And unit of acceleration is meters per second square. This is very simple question. You have been given two things, find mass. Again two things, find mass. Add both the masses. You have force and mass, but you have to find acceleration. Fine. Please pause the video and write this in your CW. Yes, so this is example 9.5, and please mark this as very important sum. Right. The velocity time graph of a ball of mass 20 grams moving on a straight line is given over here. See, this is a very easy question. Only difference is instead of providing the data numerically directly, we have been provided the data in the graphical form. આપણે ગ્રાફ માંથી ડેટા ઉપાડવાનો છે, that's it. સૌથી પહેલી વસ્તુ મને આપી દીધી છે માસ is 20 grams. તો ગ્રામ્સ માં તો આપણે કઈ કામ નથી. ગ્રામ્સ ની બદલે આપણે શેમાં લખશું? કિલોગ્રામ્સ માં. So 20 grams is 0.02 kg. Simply 20 ને 1000 થી ડિવાઇડ કરવાનો છે. So we get 0.02 kilograms. Now when I see this graph, I can see here I am having velocity. So initially the velocity was 20. But 20 what? 20 centimeters per second. એ બહુ ધ્યાન રાખવાની વસ્તુ છે. Right? This is initial velocity. This is final velocity. So initially my velocity was 20. So I shall write 20 centimeters per second. But I have to convert it into meters per second. Hence I will divide this by 100. Right? So 20 upon 100 will give me 0.2 centimeters per second. Convert to meters per second. Always be aware. Velocity should be in meters per second. Mass should be in kilogram whenever you are trying to find force. Right? Slowly the velocity decreases and it touches over here. So when it touches over here, the velocity becomes 0. Right? So final velocity becomes 0. And when it touches over here, I can see that time is 10 seconds. So time is 10 seconds. Simple વસ્તુ છે. કોઈ ઓબ્જેક્ટની વેલોસિટી 0.2 હતી, એમાંથી 0 થઈ ગઈ. Velocity was 0.2 meters per second and it got converted into 0. And for this conversion, the time taken was 10 seconds. Mass of the object was this much. What you have to do? You have to find the force. Right? So simply again we will use the formula F is equal to m into v minus u upon t. Right? Again the formula is not written over here. I shall write it for you. F is equal to m into v minus u whole divided by time according to Newton's second law of motion. Right? One more thing which is very much clear, that the velocity over here is decreasing. So definitely the force which is applied is negative to the direction of motion. Right? See, we have applied the values. M is 0.02. Initial velocity, final velocity is 0. Initial velocity is 0.2 and time taken is 10 seconds. 0 minus 0.2, we get minus 0.2. When I multiply them, I get minus 0.04. Right? And when minus 0.04 gets divided by 10, we get minus 0.004 newtons. Right? Very simple, but be careful about these zeros and decimal points. This is simple minus 0.2. Now here simply 2 2s are 4, but this 1 0 gets added over here as a decimal. And when I divide by 10, again 1 0 increases. You can see the force is again negative. Fine, so we shall now meet again in the next video lecture. Please write these 5 sums in your CW and study them well. I will send you a list of questions to practice for maths. Please practice them. And also we are trying to give you a lecture for English grammar, active and passive voice on Sunday. Fine. One thing is very much clear that majority of the students have not submitted me the homework of Hindi, which I told you to complete by Thursday night. Only a handful of students have submitted, which is alarming. So parents of rest of the students will be informed about this. If you are not serious regarding your exams, I can't do anything from over here. Fine. We shall meet again in the next video lecture. Thank you very much. Goodbye.